Okay, so Unit 5, thank you for taking the test ahead of time. I made a template actually for you to take notes, yay! So there's that. First, what I want you to do is kind of talk me through a high-level overview of the test, just like the keys to the content that kids need to know, and then we're gonna get into the specifics of multiple choice. What are the distractors? What are we thinking about thinking steps for this unit? So to just start off, what are some of the key content ideas that students need for success on Unit 5?
I think the test goes pretty much in order of the concepts of how they learned them.
Mm-hmm.
So really broad stuff from which direction does heat flow.
Mm-hmm. Let's record some key takeaways because we're gonna come back to them.
Okay, so I think it goes kind of from the broad stuff of equilibrium and which direction heat flows, and then by the end they're calculating exactly what the heat transfer was based on the last free response question. Ask them to do the calculation and figure out which one's endothermic and exothermic.
Mm-hmm.
So everything from what does that mean if it's exothermic to given information and the numbers of a reaction, how do we figure out what's going on and what type of reaction we have, and then specifically the change in kilojoules and.
Great, so I heard you say heat flow, calculating specific heat or change in specific heat.
The other big thing in the middle, I would say, is the factors that impact reaction rates.
Yes, I didn't hear you say that.
And then there's a few questions on the bond, on how that impacts bonds and how much energy is in those. But the big thing with both the lab in the middle and a lot of the multiple choice questions are how surface area and volume and
Mm-hmm.
factors influence
Mm-hmm.
rate of reaction.
Two things I didn't hear you say that I pulled out as key ideas is one, understanding the shift in equilibrium, whether it moves to the left or the right.
Okay.
And the other one is they need to know the energy diagram cold. They have to be able to interpret it multiple times.
Mm-hmm.
And they have to be able to compare to, and they also have to draw and label the entire thing. Great, so with that in mind, let's dive into multiple choice first. So there's a spot for you to record any notes here on anything that comes up tricky for multiple choice, so we can think about it. Have this on hand when we're designing practice for your lessons. So what multiple choice questions did you struggle with, and what tripped you up, and what was challenging about these questions?
In the beginning they moved pretty easily. I did highlight some of the graph ones, like you said, because there's just the options, there's very minor details, so even if they get the general idea, they have to be more really specific. There's one in particular. I think some of the ones that have charts, which is the same as some of the standards we struggled with, it's the concept is asked earlier and it's easy, but even the SALT A and B ones,
Which one?
even these ones I do think are a little bit tricky, because I have to pull the information out and then apply the concept. So I think those ones have potential to be tricky.
So I'm hearing you say for number 13 and 14, some questions number 14 and 16, reading the graph and using process of elimination. One of the things I noted for every single question where it's a graph and text, they had to choose to match it, they have to use process of elimination. That's true for number 14, 16, 22, 24, 26, there's so many questions in which they have to use the graph and do process of elimination. And then repeat what you said about the pulling data, because that was a great insight, for number 9.
The concept of answering that question is pretty straightforward, but they have to be able to pull the data correctly from the table, which we know is something that we struggled with on the last IA. So I think those might be challenging, because first they have to kind of make sense of what this is saying and then be able to think about what's going on with that.
Yeah, no, IA3, there's some questions in which they have to just pull data from the table, but more often than not, they have to pull the data and make a conclusion. So I would note that for number 9 and 27 and 29, they have to pull data from the table and use it to make a conclusion. Whereas in the past, all they had to do is pull data. It's interesting for a question like number 2, they have to pull data from one set and make a conclusion. I don't even know what that noise means. They had to pull data and make one conclusion, and the other ones they have to pull data from 2 different sets and make a conclusion. Like that's more often what they have to do on the IA, and so like, although on these, just make a note to yourself, like although like for number 9 and number 2 and number 27, they have to pull data from one set and make a conclusion. Just make a note to yourself that on the IA they have to pull it from 2 sets to make a conclusion, so kids are gonna need to practice with both. It's good that these tables are on here, but it's not as rigorous as this. IA. Okay, any clear distractors in multiple choice?
I think with some of the graphs, there are some that are meant to look similar. I think with the some of the graph ones we just talked about, they have to be really careful about just like labeling and titles, because if they just look at the label the wrong way, it'll shift their answer, especially if it's process and elimination.
So mislabeled things, I would say, is a distractor. The only thing that I put down, I don't think there's any super clear ones, the only thing that I put down is the opposite answer is always on here. So they really need to know, the opposite answer is always on here. They have to know cold, that exothermic means energy exiting or heat exiting, that's how I always taught it. Not very scientific, but it sticks, exit, exo. And that endothermic is like, inside is what I kind of taught kids, because everything is the opposite. Same thing with the shift left. Anything there's a shift left, there's gonna say a shift right. So this is gonna be one of those units where, like we talked about in your mid-year evaluation, like you're really gonna have students defend and explain their answers. For why is it left and right? Why is it exothermic? Okay. Are you ready to move on to open response? When I looked at this, I was like, this is similar to what they have to do on like a college. This is way more similar to what they have to do in a college exam.
Yeah,
I appreciated.
Even number 1, I felt like these were just like something like number 1. There's not a lot of guidance in where they're going next, so I think they really just have to like the first one took me a while and a lot of looking back and remembering how to do this. So there's like there's just a lot they have to do, and even though it kind of gives them some stuff, they just have to know what it looks like before they get there. It's pretty just blank, especially because there's no labels or anything, so I think the free response is pretty challenging.
I do, but I think it's like the most straightforward out of everything we had. It's not over, I think some stuff has been over scaffolded in the past, and I think this is like really realistic of like the free response questions they'll see next year in APES. So let's talk about this. What did you notice was challenging specifically about each question for yourself? What are the biggest challenges in the open response? I already heard you say like drawing and labeling each part of the activation energy diagram. That's the first thing I wrote down. You really have to know that cold.
And then I think for number 5 and number 7, I do think one of the things that's challenging is just like keeping it, there's a lot of work they have to do to get to the final answer, so there's like multiple steps and there's a lot of stuff to keep neat in order to get to the end, so I think that's something that's gonna be challenging for that.
Right, I captured down they need to know how to annotate a table and use the data in the table to complete their calculation. So it's like the skill of annotating and using data in the table and then correctly pulling it out to calculate. What about a question like number 3 is like the baby version of question 8. What do you think about question 3, 6, and 8 are all asking the same thing?
Yeah, I think it's the same as some of the others. some of what we said earlier in the multiple choice, that there's always the opposite option, so we know that going into that, the process of being able to explain what is endo or exothermic, providing data that supports that, and then connecting why those two are related. Like, even though this isn't technically CER, like, even in one sentence, it kind of is.
It is, you have to explain and defend, so I would say, to reiterate again, we've already said this, but like, they really have to explain and defend this unit. One thing that's like really cool about this unit, and I think this is gonna be your hook, like day one, you gotta say like, listen, like, you really don't have to know previous content to be really successful with this unit. They don't. They don't have to balance equations or anything for this unit. And so I think that you can really hook kids into that and say like, if you walked into chemistry today, you could still do this unit. The only thing they need like a little bit of previous knowledge for is the moles and the
Yeah, I was gonna say number 5, they're gonna
Number
need
five.
some of that part.
But otherwise though, it's not gonna be like
Yeah.
some of the stuff that they have struggled with, some of the stuff they have gotten frustrated with.
It's gone.
Yes. Yep. Okay. The last thing is thinking steps. Now there's a lot in this unit, but let's kind of talk about some of the lessons that it's gonna be really important for you to do thinking steps for.
Specifically, I think any of the ones that they're moving all the way through, so like all the free response ones that have a lot of the calculation, thinking about like number 5 or how to pull the data for number 7.
Right, so kind of
Because
what we just
they're
talked about,
opening,
so like
yeah.
the thinking steps and pulling the data and calculating, we already wrote that down. What else?
I think again, there's so many with like rate of reaction with exo and endo, it's like that connection between like the data or whatever you're given, and then being able to connect that with like either a definition or a direction. So it's like they're given the information, they have to figure out the cause, and then the answer is usually the effect. So I think just going through kind of cause and effective data is gonna be something that's gonna have to be reiterated with thinking steps.
I would write that down, because that's not something I even put on my notes, is like the thinking step of understanding cause and effect is so important. I'm gonna add that to my notes too. Let's see. The only other thing I wrote is that they're gonna need to, and this goes along with cause and effect though, is like interpret their calculation in context to determine a conclusion, right? Like to see like, okay, this is my change in specific heat, does that mean it's exothermic or endothermic? They have to do about, in the algebra curriculum, they have to do a lot of evaluating answers in context to see if they make sense and then explaining them. Okay, let's move on to the weekly lesson grids, and I brought, where are they? I brought a copy for you too, so we can kind of mark them up together, but before we dive into this, let's stamp again, what are some of the key ideas for this unit? Like, what are the big ideas?
Energy shift, so exo-endo,
Yep.
energy shift, like context of what's gonna impact rate, and then the graphs, the energy graphs, and direction understanding.
Yep, and the only thing you didn't say, and it's because we talked about it before this meeting, is they have to be able to read data from multiple tables. So that's not in this unit, but that we know that's a huge thing for the IA3. Okay, let's kind of go through each week, and what I want to do is make notes on where we can add some extra practice with some of the skills we need, which is drawing those graphs and reading data from multiple charts, and make notes on where we might need an extra day, given that we know like our big focus areas. So, looking at week 1, why don't we take like 2 minutes and look that over and think about like where can we add an extra practice and where might we need an extra day?
The other thing with this one, in trying to find, so I had week 1 flagged as maybe an extra day to do some stuff. One, because we know that data is gonna come up a lot through the unit, so maybe it'd be good to do a day to look at that, and then also trying to get this to line up with our long block days. So I flagged week 1 as a place where maybe we do some like reading data work before we start doing it in the context of like new science for them.
And where do you think would be an appropriate, given our big ideas for the unit and what they really have to know cold for the unit, where would be the most appropriate day to add some more practice?
I was thinking that this first day to kind of get the right terminology and vocab, and then in between that and planning and conducting their investigation. But that's also based on wanting to fit 3 into a Thursday, Friday.
So just to clarify, are you meaning between lesson 1 and 2 or lesson 2 and 3?
2 and 3.
Summarize the terms and they'll be. And it does have IOD 304, the reading charts one, which is like super important for the next IA. And so if you were to add a day here, and do something with like reading data from multiple charts to make conclusions, that would align to IA and give them extra practice for what we know they need to do. And that's good too, because I saw that you did have a day on there for ACT practice, but we decided to punt that experimental design stuff anyway, since it's not on IA3. Great. Okay, the only other thing I would say for week 1 is that you do have on this last day the potential energy diagrams. So make this is definitely one where we know that they have to read all those diagrams and a lot of multiple choice, and they have to draw one, too. And this is the only day that they learn it.
Okay.
So I think an extra day there would also be useful. Like, we'll look at the exit tickets together for this day, determine what needs to be retaught, so maybe we'll meet like the next morning or something like that. Awesome. Okay, so for week 1, we're gonna add something after the terms and stuff like that to like reiterate the terms, but also give them practice reading data tables. We're also gonna add some time after this potential energy diagrams to make sure they can not only read them, but like draw them and label all the parts.
Okay.
Because this is a doozy. Cool. All right, let's go on to week 2. Anything we can add in some more practice or anything that we need to tweak?
I think there's a lot of the molecular collision one.
Yep, it's a big important day.
There's a lot of there's a lot of multiple choice questions on the rate of reaction, but there is sort of a built-in day then right after. So maybe we can try to use some of this content, but keep some of this standard for the day after.
Right, so this IOD 404, you've already decided in the week previous to build in some extra practice with it, so that'll be there. So when you plan this lesson here, I would still keep some practice with the charts and tables and keep it, determine it based on the exit tickets from your extra practice day, but also, so I'm envisioning, sorry, I'm not being clear. So this lesson is kind of like a practice with charts and quiz, so you could do like half the lesson to address the gaps from your chart.
Okay.
Exit ticket data from the week before, and half the lesson to address gaps from your exit ticket the day before on rate of reaction. So it's like a 50-50 kind of lesson. Alright, so what are you doing on this day? Because I was not clear, I just want to make sure.
So we can have some practice for IOD 4, but we'll have, we can look back at the graph data that we know is important, and then also we are addressing some of 404 in the week before. So we'll have more time here to spend looking back at the exit tickets from the graph.
So exit tickets from the graph on this day, yep, and also exit tickets from the, not the diagrams, because we put an extra day in there already, but from this rate of reaction.
Okay.
Because the rate of reaction aligns with all those, like 28, 29, 23, all those questions. So what are you doing here again, just to make sure?
Some room for practice with IOD4, but to respond to exit tickets from the rate of reaction that they
Perfect, great. All right, let's keep going. Week 3. Yes.
So I had put going into week 3, this is gonna be the week of the IA, so I shifted some of this down to take another day before
I
during
think that's
this week.
smart. I think that's smart. I think you should keep that day. I saw it on there. Draft your plan.
And I have that as TBD right now in terms of like what,
I have an idea. What else you can talk about, but
I have that blank, and knowing that we just probably wanna take a day before the IA to do that.
the only thing I would say here where I think it's like the most important lesson of this week is lesson 4, the concept of equilibrium and how a chemical reaction reaches equilibrium level and like understanding the shifts, because they're gonna have to really know that for, which are those? 17 and 18. So that's really important on that day. Okay. I think that's good. So we added in a day to do some data table practice after the terminology day to make sure they have that vocabulary cold, so that way the distractors hopefully won't get them and the opposite answers. And then we added in a day with the activation energy diagrams to make sure kids know that cold. Perfect. All right. So we kind of just talked about CCRS stuff, and I do think it's smart to punt the SIN standards to later since they're not emphasized, and they're also getting practice when they design this lab. So really, what's the big CCRS skill you have to drive home this unit whenever you can?
Pulling data, which is the IOD.
What specifically about pulling data is like amped up this unit?
For being able to pull data from one or two complex presentations, and then not just finding the data, but interpreting the data and coming to a conclusion.
Perfect. So anytime you have a chance to do that this unit, do it. Anytime you're like, I don't really have anything for homework, that's what they should do. Okay, so thank you for already drafting unit 5. I saw that in your quarterly plan, above and beyond. I did see that you did the 2 ACT prep days. I think you can take out that first one like we talked about and save it. See how you put, did you already fix it? Look at you already fixed it, that's crazy.
So the other one
You had here, yeah. You can take that day out.
Got it.
And that will help because you already did end in the data one, which is smart.
Okay.
But you're gonna have to add in that extra day we talked about for diagrams.
Okay. How the only thing, and I hit this a lot with planning, is like this heat flow is supposed to be a lab, so I have that on the long block day. So sometimes I feel like I run into. Sometimes I can just split them. If it's just a big concept, I can split into 2 classes. But if it's a lab, sometimes it's tricky to.
That makes sense. I think that you could move these 2 guys up and take this endothermic, exothermic here.
And put it before. Okay.
And what will be good about that is, when we first talked to this a few minutes ago, we said, we'll meet that day and we'll do we'll look at the exit tickets, and the next day we'll reteach it. If you do it here, that'll give us time to meet Thursday, Friday, and then Monday you can address any gaps from those energy diagrams, because we know how important they are for multiple choice and for this 5-point open response.
So the this one that's highlighted.
Yep.
Will go in between complex presentations and the lab.
Yep. And you can make this Monday day be like endothermic, exothermic, like day 2, and like really making sure they understand those potential energy diagrams.
Okay.
So this is like a kind of like day 2 reteach day, and we'll plan that Thursday and Friday of the previous week. Since you had already been smart and added in the data from Mohammed's presentation, looks like you're in good shape. here's two things.
Mhm.
One, I want you to include a CCRS quiz on reading data from multiple presentations. Looks like you could fit it maybe even right here.
Okay.
There's a couple on KipShare, just look at the one that, most aligns to the standards on this IA. And you can use that quiz data to, for that other lesson. And then, you got that? And the second thing is, I noticed for IA3 for questions, what is it, 13 through 19? They have to know that lower pH means it's more acidic. They have to know that, and that doesn't naturally embed into this unit. And so make a note for your ACT prep day that you need to somehow incorporate that concept into that day, the day before the IA. So what is it, the 14th? You need to just make a note to yourself to address that lower pH means more acidic. And also to address those hot words we talked about the day before, like accept, but, always, contradict, support. Awesome. So this unit, instead of weekly quizzes, I don't think you necessarily need to do them. We have those like 5 big ideas. I didn't see them noted on your plan either. You put them in there? I didn't see them.
No, I generally try to fit them in my head, it's just like they generally should go into the long block, and then deciding what to quiz on usually.
Since this is a short unit and there's like a clear 5 ideas, rather than doing weekly quizzes, I think it makes sense to do data meetings for those key lessons, like the activation energy diagrams. We can plan the reteach, the rate of reaction day.
And we'll use exit tickets for
And we'll use the exit ticket for that, and the shifts in equilibrium day too.
Okay.
So what I'm gonna do after this meeting is send you calendar invites for those.
Okay.
And you already have your quarterly plan updated, so great. That was gonna be my only action for you, is update your quarterly plan, but you just did it.
And then canceled weekly data meeting this Monday, because I think we have next week.
Yes.
Okay.
Yep, I canceled it. We also are not here on Monday, remember?
Oh, right.
Oh, right, just 3-day weekends. Yep. Do you have any questions for me?